Welcome. In this lesson, we're going to take a look at the binary search algorithm as a really fast way to find elements in an array. So let's get started. Today we have two learning goals. The first one is that we want to be able to explain the binary search algorithm and use it to solve problems. But then the other one is that we want to be able to compare this to the linear search that we've already learned about and be able to explain the advantages and disadvantages of choosing a linear search versus a binary search. An alternative to linear search is called binary search. And binary search is really designed for situations where you are searching through a lot of stuff. Again, think like the internet. And when you have a lot of stuff, like billions and billions of things, linear search just isn't fast enough. In fact, if Google used linear search, you'd probably type something in the search engine and have to come back, I don't know, maybe days later to actually see the results. So binary search speeds this up, but there is a catch. It only works on lists that are sorted. And the reason it only works on lists that are sorted is because it leverages that sorting to speed up the search. So here's the basic algorithm. And if this doesn't make a ton of sense, that's okay, because we're going to go through an example on the next couple slides. So what we do is we have our sorted list, and we're going to look for the middle index. Now that's different right away, because with a linear search, we start at the beginning, index 0, and we're not going to do that. We're going to start at the middle. And if the middle element happens to be what we're looking for, if it's a match, then we're done. Otherwise, we're going to repeat the search either on the left half of the list or on the right half of the list. So to understand how that works, let's actually see it in action. In the upper left, you see that I've created an array. And what we would like to do in this array is search for the number 9. Now, I know you aren't stupid. You can see that the number 9 is located right here at index 5. But let's pretend we don't know where it is and see how binary search will find it for us. It's really important to notice that this list is sorted. -6 to 21, all in increasing order. So our first move is going to be to identify not the beginning of the list like we would in linear search, but the middle element of the list. And the way we'll do that is we'll take a simple average. Our left index is 0. Our right index is 9. If we add those together and divide by 2, we get 4. So we'll just do integer division because obviously there isn't such a thing as index 4.5. So index 4 puts our middle right there, and you see it highlighted in blue. And so what we have to ask is this element 8, is this what we're searching for? Well, of course, we're searching for a 9, so it's not. However, the news isn't all bad, because now what I can do is eliminate half my list. Why? The answer is because it's sorted. If I look at this 8, I say 8's not what I'm looking for, 9 is. And then I ask myself, is 9 bigger than 8? Or is 9 smaller than 8? And since I know it's bigger, I can wipe out half my list on the first move. So that's incredibly efficient. And now I'm just going to repeat the process again. So I'm going to identify the middle element with only the part of the list that I'm interested in. So here's my left, which is index 5. Here's my right, which is index 9, and with a simple average, I can find that the middle element is element 7. And element 7 is not what I'm looking for. However, I can eliminate half my list because I'm looking for 9. And so I can ask, does 9 occur, is it bigger than 15? Or is it smaller? And of course it's smaller, so I will eliminate the right half of my list. And so now in just a couple moves, I'm already down to 2 elements. So let's find the middle. Left and right are really close to each other now. Left is element 5, right is element 6. If I add 5 and 6 and divide by 2, I find the middle index is indeed 5. And then I ask, is element 5 my search target? And of course, in this case, it is. So our item was found at index 5. The total number of items we examined was 3, versus a linear search, it would have taken 5 moves to get here. It is possible that when you do a binary search, the thing that you're looking for might not be found. So basically what happens is this. We keep cutting the list in half and in half and in half, and eventually we get down to just one element. And at that point, if we get down to just the one element, either that element is the thing we're looking for or it's not. And if it's not, the search has failed. But whether or not it's found, binary search will always end when the left index and the right index collide with each other, when they become equal. Now, if you remember, the left index originally started way on the left side, the right index started on the right side, and those two have been getting closer and closer to each other as we cut the list in half. And when they become equal, when they intersect, the search is over. At this point, I may not have convinced you that binary search is really that much faster than linear search. After all, in our example, linear search would have taken 5 iterations, 5 moves, and the binary search took 3, not a huge difference. But binary search ultimately is fast because it eliminates half the possibilities after each iteration. So for example, if we started with a list of size 32, our next move we would have a list of size 16, 8, 4, 2, and then finally 1. So we could search through 32 items in just 5 moves. Of course, with linear search, worst case, it would take 32 moves. So binary search is a little faster there. But the thing about binary search is it gets better and better the bigger your list is. So let's say, for example, you wanted to search the entire population of Earth, which is 7.5 billion people. Well, it turns out that with binary search, that would only take 33 iterations. And with a linear search, worst case, it would take 7.5 billion. So that cutting in half for large lists is incredibly, incredibly efficient. So when you have to do some searching, you ultimately, as the software engineer, have to decide which search do you want to use, binary or linear. And the answer is there isn't an answer. It really depends on the situation. And so you need to be able to evaluate the advantages and disadvantages of each. With binary search, when speed is really important, that's a great indication that a binary search is worth your time. You do have to make sure the list is sorted. So if it's not already sorted, then you have to go through the effort of sorting it or keeping it sorted as things are added to it. And you may have noticed when we searched for the 9 in our list, once it found the 9, it was done. And so if there was more than one 9, if I needed to find all of them, binary search wouldn't do that without putting in some extra effort. So binary search, you have to care enough about speed that you're willing to put in the extra effort to make it work. Linear search, on the other hand, is very quick and easy to implement. So you use it when you're not super concerned with speed, when you have a small list, because with a small list, it's going to be fast no matter what. And of course, when you need a quick and simple implementation. Now that you've seen this lesson, you should be able to explain the binary search algorithm, and we're going to be able to use that to solve problems in the exercises. And the other thing is that you should be able to explain the advantages and disadvantages of choosing a linear search versus a binary search.